for purposes of sharing the video later. Yeah. So we are going to start with problem-oriented teaching method. And this particular teaching method has its history in medicine, but researchers are now realizing that we can use this teaching method within computer science and IT and anything ICT related. So this particular teaching method is student-centered. So it gives quite a great deal of, it takes quite a great deal of tasks back to the student themselves. Unlike some of the traditional teaching methods like lecture, which gives focus to the lecturer or the teacher, the problem-oriented teaching method can also be applied in IT, and especially those practical IT courses. Now, most of the time, especially in our developing context, we find that, or we assume that a student may have little or no knowledge where any ICT subject is concerned. But that is not necessarily the case. People are getting more and more tech savvy. And also, once you hand power over to a student, they take ownership of what it is they are studying. So problem-oriented teaching method can be very, very effective if you especially divide up your subject into a series of tasks, or a series of tasks and functions from a required tool. So here, what do we mean? You have if you have you have a learning objective, which can be split into several tasks. That if I start from point A and I carry out tasks 1, 2, 3, 4, I will arrive at point B. I would have picked up certain skills and knowledge along the way. Once you have that kind of material or content, which can be split into tasks, then you can use problem-oriented teaching method. So here the tasks are a structured part of the daily program or routine. So what you see, each task becomes a teaching tool. Each task that needs to be learned becomes, or activity becomes a teaching tool, so that you keep moving from one task to the next. Now, there are certain things that need to support this particular teaching method. So if you're going to use problem-oriented teaching method, there must be some kind of existing knowledge. That means the student must have some kind of existing knowledge as far as that application is concerned. What do I mean? For example, if you are going to teach ICT literacy, or in particular computer literacy, and you're going to need the student, let's say, to develop some kind of application, some kind of document from any of the applications in the Office package. The Office, I mean Microsoft Office or OpenOffice, whichever it is you're teaching. But you require a student to produce a document which has several formats. That means the student must have some knowledge of that application. Maybe it's a word processing, or it is a presentation software, or it is it's an application like Excel, a spreadsheet, or like Excel, and so on and so forth. There must be some kind of existing knowledge. so that you require the student to, these students to go ahead and resolve that problem using whatever application they need to use. Let us assume your students are doing programming and you give them a problem. So that problem, for the students to solve it, they should be able to, have some existing knowledge of the programming language which they are going to use. They must have some existing knowledge of the program, the editor, the language editor that they are going to use, so that they can resolve the problem. Essentially, a problem-oriented teaching method is saying that there is an existing problem and I need to resolve it using all the tools that are available to me. So, this is the first thing that is required. Two, there must be some knowledge, aesthetic knowledge. That means, by aesthetic, what it means is that they should know much more than just the basics of the application that they are going to be handling. What do I mean? If, let's say, you ask your students to work on a Word document, for the students to work with a Word document or to develop a certain Word document, they must know, first of all, how to use a word processor like Microsoft Office. They must be able to edit their document using that word processor application. They must have some knowledge of some do's and don'ts for editing. Take an example. If I asked you to produce something using a PowerPoint, you should be able to use PowerPoint to up to at least a minimum level. Maybe you're able to add a graph, or to add a picture, to put some animation in your PowerPoint presentation. So adding those aesthetics, you must have some knowledge. Let us assume it is programming, the same thing. Take an example. By aesthetics in programming, we could think of something like a complex algorithm to make to resolve a certain need that the problem you presented to the students must be done. This third point you see here, thinking and planning, is a key point, because in problem-oriented teaching method, you're asking students to become analytical, to become critical, to become thinkers. Like any problem that I may give you, take an example. If I came and told you that, let us say, I have a challenge, I would like to communicate with some students of mine who are in remote rural areas with limited or no internet access. So for you to think of a solution for me, it means you have to take time to think about it. You have to take time to read and conceptualize, be critical, be analytical, so that you can come up with an appropriate solution for me. So that is essentially a problem-oriented teaching method. This is what it requires, that one is able to resolve the problem. The last one is familiarity with the tools. So this essentially goes back to being able to have some knowledge, so that the tools that you're going to use to develop or to resolve your solution, you must have some knowledge. Like I gave an example, you must have some knowledge of word application. You must have some knowledge of programming and any editors that you may need to resolve sorry to solve the problem. Before I go further on 2 steps on problem, the problem learning method, do you have any questions so far? Does anyone have a question before I continue? No? Okay, so let me continue. There are generally 7 steps that are required if you're using the problem-based learning method. 7 steps. The first, different writers pinpoint, they may switch the steps, they may add something, but essentially it's agreed there are 7 steps that should be taken when one is using the problem-based learning method. One is to explore the issue. So you give your students, like I gave you the example of, let's say of myself, if I say that I have students who are in remote areas with limited or no access to internet, but I would like to have to transfer some of my teaching online to them. And then I ask you, help me come up with a solution. So the first thing is you begin by exploring the issue. So you gather information. You may go online and try to find out about remote learning with limited internet resources. What have other people done? What technologies are available? What technologies can be used? How can they be used? So that is the exploratory stage. So you can already see if you use this approach, you need to ensure that your students essentially have access to this information. For example, that you have a good library, which library gives you to a number of resources, whether physical or electronic, and that your students know how to access that kind of information. You may also need to know if they have some information literacy. What does this mean by information literacy? If you're going out to gather information unguided by a teacher or essentially independently, you should be able to gather information and interpret it properly and then reuse it appropriately. That's information literacy. So this is in itself is also a skill. State what is known. So this can be done in groups or as individual students. Key point is that once you're using the problem-based learning method, you must, it's normally a good idea that it's done in groups. Within the groups, the students can split up their tasks. Take an example, a group can, the group members can all go out to explore, then they come back together and consolidate what they have. They agree or they disagree, and then they agree on what to present, the line they follow as a group. So as they state what things are, they also outline the scenario and list what areas that are where they are lacking information. So even with the problem itself, leave aside what the students have gone out to research, the students may also decide to reorganize the problem into scenarios which can be sorted out one by one. So take an example, the case I gave you of wanting to carry out some teaching to some remote students. So one of the things we know that we want to teach students remotely and within the context of limited resources. What do we mean by resources? Are we talking about devices? Are we talking about internet? Are we talking about quality of internet? Things like that, and you list them out. Then you go ahead to begin to think of a solution for each of them based on researched information. Define the issues. So already from stating what is known, you actually begin to define the issues. Frame the problem in a context of what is already known and inform the students what you expect them to learn. So these are the first 3 key points. The remaining 4. Research the knowledge. So that means you find resources and information that will help you create a compelling argument. Number 1, to define, yes, your problem, but number 2, to present a solution. So as you're presenting the solution, you investigate several solutions and pick the best the best possible solution out of the many. So once you've selected it and preferably applied it, you present it and give it support. That means you defend why you've picked that solution. Then also review your performance. So sometimes for some literature, you'll find that the last point here given has actually been split, so that presentation or reporting comes last. But some other writers insist that you must have a review. That means that students evaluate their performance and see where there is need for improvement. Do you have any questions so far as problem-based learning and the 7 steps I have pointed out? Do we have any question?
I think we can, Doctor.
Okay, let me move to the next. So this diagram gives a summary of the steps that you go through. So essentially summarized, everything starts with understanding the problem. So the group must understand the problem, explore the curriculum or gather information, then resolve the problem and report it. Those are, if we look at all the 7 steps, they can be summarized into these 3 steps. Some pros and cons for using problem-oriented or problem-based learning. Number one, it will lead the students to logically understand the application. From what they'll be able to understand the different sections of your learning, especially if it is you're looking at different applications. Let me just put this on the side and minimize it. Yeah. So if a solution requires your students to use more than one application, the students can then easily see the interrelationships between different applications. So I'll give you an example. Say you have given your students, those who are teaching IC literacy, you've given your students the required solution would probably be a report which has both texts and graphs. What that means is that your students are going to use Word, then they use Excel in order to resolve the problem. If it's going to require them to present something maybe in PowerPoint format and present figures, then they may end up using both PowerPoint and graphs as well, which allows the student to use more than one application. Let us go to programming. The same thing. If you gave a student a problem and they have to come up with, let's say, a software program, what is happening? The student is going to go through a design process and then also go ahead and develop an actual software application, which means the student is, number one, honing their design skills. And if they have to use an application to come up with a design, they are also then gaining more proficiency and skill in using that application. Then also the same thing if they have to develop a software, what it is they are using also helps. Somebody is putting in a comment. Andrew is saying network is unstable. Sorry about that, Andrew, but we are recording. You should be able to access this later. So if the application leads, if the problem leads a student from one application to another, or that means that you're seeing that that first of all, the student is gaining an experience to see that to resolve a problem, you can't only focus on one thing. What do I mean? Let us just think of programming. If you decided to follow only instruction, that means a lecture instruction teaching students how to program in a certain language, probably the only thing the student will pick out is maybe syntax, because they are typing out syntax in a language editor, in a programming editor, as opposed to giving a student a problem, and the student, first of all, learns to analyze the problem, develop, understand it, design a solution, and then apply that solution into a programming language. Here, the student is becoming an all-round student. The disadvantage to it may be a lack of information, where a student can be able to go to pick some knowledge on how to resolve that problem. So here, when you don't have enough resources, it becomes a challenge. Remember when I was giving you some of the prerequisites to using problem-based learning is the need to have access to resources. So resources like learning materials, or even resources like the actual applications themselves that the student will need to resolve the problem. We come to our second teaching method, which is application-oriented. Previous was problem-oriented or problem-based learning. This one is application-oriented or application-based learning. So with ICT, we are basically using applications or devices. Yes, we are using applications or devices. So with application-oriented, what the teacher is focusing on is to teach based on the application or device that that the student needs to learn. So now this particular teaching method is very good if your students lack knowledge on how to use a certain application, or they need to build on it, that the teacher or the lecturer focuses on the application itself. So the same thing as problem-oriented or problem-based learning, it's a structured style of learning where you have a series of tasks. So what do I mean here? Let us say I want to teach you how to use PowerPoint. PowerPoint itself, as an application, has several, there are so many, as an application is quite rich. So I may decide to focus on, as a teacher, I will decide to focus on the application of presentation, split it up into tasks, then ensure that we go through each and every task, so that at the end of the day, you as a student or your students are proficient in that particular application. Yeah. Now, the big difference between application and problem-based learning, it does not aspire to teach every possibility. What do we mean? You notice that with problem-based learning, where you have an existing problem and you begin to drive through several tools or several applications to solve that problem, this one is not looking at a problem, but is looking at the application. So one may focus on presentation. Also, for example, the presentation applications like spreadsheets or PowerPoint, but may not necessarily focus on Excel and generating graphs, which may be necessary to include in the application. You may not focus on maybe developing videos, things like that. Same thing goes with if let's say you're looking at programming, you may be looking at a particular application. For example, you may decide to focus on one particular aspect of programming, which may be developing interfaces, and you focus on that, but you neglect others like algorithms, um, connecting to a database, and so on and so forth. So here, you're dealing specifically with the application itself. Here are just some examples of the kind of content you may find. We have an application called desktop publishing, which deals with newspapers and books. So you may decide that let me teach the students how to come up with a newspaper using desktop publishing. You can also combine it with problem-based learning, by the way. You can combine application-based learning with problem-based learning so that you hit two birds with one stone. If you look at drawing, you may decide to look at posters, lines, illustrations, and so on and so forth. Same thing with spreadsheets, and we can bring in even more applications. So far, that is applications. Do we have any question on applications? Yes, Andrew.
Yes, doctor. I'm seeing when I compare the two teaching methods, that is the problem-oriented based and the application, so I think there is a need that one can use them one in hand.
Yes.
Because if you identify
Mhm.
that there is a problem which needs to be worked out, first of all, one needs to learn the strategies on how it's going to work it out.
Yes.
Then later it can be really worked it out. So
Yes.
without problem based, then there is no need for one to empower the application oriented.
Yes. Yes, Andrew, you're very right. You can combine, you can mix and match your teaching methods so that you get the best of both worlds. There might be situations when where there may be there may be certain content where one may need to focus strictly on one method over the other. I'll give you an example. There are times when, let's say in programming, you may be starting for the very first time with your class, and you wish to show your students how to write a certain program, or certain applications that you may need, certain tools that you may need. So take an example in programming, let's say Java, those who are interested in software programming. Let's say sometimes when I was first going to just start teaching Java, if I'm going to teach Java, the students need, first of all, to have the basic tools which are necessary for programming with Java. So for example, they need the JDK, Java Development Kit. Usually the Java environment already exists on a computer, but just to make sure. Then they also need an editor, a language editor. Just like any language, for example, if I'm typing a document I need Word. So also in programming, you also need editors. So usually for the first time, when you're coming to a class, you may want to introduce these applications and give at least a student a rundown on this application and how you can use it. There you may focus strictly on the application itself. But once the student has grasped some knowledge, you can then introduce problem-based learning and then include it in together with the application so that the student picks the best of both worlds. The third method is menu-oriented. So this third and the fourth that is going to come as some of the most discouraged teaching methods that the professionals give, because really they are taking the student to be practically like somebody who has absolutely no knowledge and cannot manipulate themselves through anything. But here, menu-oriented, it's looking at an application and then going through the menu of what the application presents. So take an example. If you open up Microsoft Word at the very top is going to have a list of a menu of what it can do or what services it offers. So the teacher here would be focusing on that menu and saying, let us go through item by item in order to learn how to use a certain application. The same thing can happen also with programming or even networking. Let's say in programming, one puts up a menu of all the things that can be done in programming and decides to teach one by one. Now you realize as we go from the first three onto the next two, we are moving away from student-centered to teacher-centered. So menu-oriented more or less is pushing the teacher forward to take students through item by item. However, you can also use this on the flip side. You can ask students to go and discover what each item on the menu does, so that they go out and rediscover it, then come back and present to you, the student, or come and show their fellow classmates what each item does after they've gone through it themselves. So here is, I'm just showing a sample of how a lesson, for example, someone would plan their lesson and use the menu. So if you can just look through it, each item gives a time limit. Let us say building blocks of a text. Someone may take 5 minutes to look at the characters, the word, the paragraphs, how to come up with a paragraph, and so on and so forth. Then how to edit that paragraph. So each of these items, this is how a teacher would plan it out. Yeah. We come to the fourth, function-oriented, which is quite similar to menu-oriented. So here, we are looking at the functions of the application, and we want to go through it function by function, just like the menu item. So here we also have a sample of how you would plan out the activities for function-oriented or function-based learning. Do we have any questions so far before we move to concept and abstract? No? Okay, let's move on to concept-oriented. So in concept-oriented or concept-based learning, we pick out concepts that are existing in a particular subject or topic. Take an example. You look at this example that we see here, where let's say you're teaching Excel as an application, you look at the different concepts that exist. For example, a cell, a row, a column, a block, and so on and so forth. Translate this to all other applications. Let us look at another subject, let's say of networking. You may want to look at things like a router, a switch, traffic, packets, all the different concepts that you may find. Now, in any subject you're teaching, there will always be a concept. And this concept it may require some understanding. Yeah, it may require some understanding. So it's also a good idea to pick out the basic concepts within your subject or topic and use this method for one to learn how to go through it. Let me give you let's even go further to, let's say, programming, one of my favorite subjects of teaching, programming itself. In programming, there are many concepts that we find. An example would be, we have variables. The term variable, it's a concept. In object-oriented programming, we have a concept of classes, something called a class. We have a concept of inheritance, of a parent and child relationships, things like that. All those are concepts which a student must understand clearly before they can apply it practically in programming. So you look at those concepts which a student must pick or must understand before they can begin to apply in the practical context. So here is an example. For example, here in word processing, where you may require students to understand what a character is, a word, bullets, columns, margin, a picture, an object, because you may find a picture and an object in Word are two completely different things, borders, referencing, so on and so forth, footnotes, style. All these are concepts which a student may need to first understand before they simply go in and know how to manipulate the menu and the different functions. So here is another example of drawing things, certain concepts that somebody may need to learn. Just as a key point here on concepts, I remember I was overhearing one of my nieces was learning how to use, what is this application? Photoshop. And a colleague of my older sister came and he was showing her how to use it. And you could see as he was showing her, he kept going back to the basic concepts of Photoshop, things like the canvas, the size of your drawing. Is it going to be on an A5 or an A4, an A3? What are all those things? And just looking at the application, how you can tell. I remember him telling her that just looking at this, I can tell this is an A5. You know, things like that. There he was already bringing up the concepts before he began to go into the practical elements to show her what exists within the application and within and under the menu and the different functions. Here's another example for spreadsheets. So key point is to, number one, be able to identify the concepts. Number two, put them in their right order so that as you're taking the students through them, the student can see the relationship between the different concepts and how one leads to the other. The final teaching method is the abstract tool oriented. Yeah, abstract tool oriented. This teaching method is applicable when you especially want to give a historical or background context of your teaching or your content. A case in point, if you're going to teach, let's say, computer literacy, you may want to give a history of what existed before the computer and where the computer is moving to. So if you look at this example here, you're looking at somebody maybe beginning to talk about the typewriter, the mechanical typewriter. I don't know if any of you even knows what a typewriter is, but you can go and Google it and find out. There should be some images. What existed before the computer itself came. And when the computer came, the makers of the computers or the developers of the softwares started with a word processor, which mimics what a typewriter used to do. So so in the abstract tool learning, it will even show the relationship between the two. So this method is essentially, it's like trying to show the student the possibilities of the new tool they are going to learn. And it may be especially good if you're moving students from something they know to what they don't know. I'll give you an example. There was a teacher who told me that when he's teaching computer literacy, he would start with the simple basic phone, that is the button phone, and show them, can't you type this on the button phone? So therefore, also with the same thing with the computer, you can type using the buttons that exist on the keyboard. So moving from the known to the unknown. The challenge may be in if there's a huge difference between the traditional and the modern. That is where a challenge may exist. So here I have a small evaluation of the different methods. I think I have attached this document. You can, a document which looks at all the teaching methods. You can go through it. But essentially, each teaching method has its merits and demerits, and some may be particularly may not be move with the times, especially with the times of being student-centered. The problem-oriented and application-oriented teaching methods are especially good if you want a student to have a holistic learning. And they are also best suited for certain cases. So for example, problem-oriented, problem-based learning can be used both in primary and secondary schools. They can be quite good, but also for higher level, university level, these are quite good. If you want students to learn things like algorithms, problem-based learning is very good. Application-based learning is best for vocational training, but again, it can also be used both at secondary and primary level as well as university. Like I had discussed earlier, menu-oriented and function-oriented there are two methods that should not be widely popularized, especially menu-oriented, because it almost assumes the student is a dummy and must be taken step by step. So function-oriented can also be the same as menu-oriented, but it can be developed further so that it's used, let's say, when you're teaching algorithms. It can be developed further. What do I mean? If you may decide to say, let's look at a function of a piece of software and develop that function. If it is in computer literacy, this can become almost like a dummy against, just like menu-oriented programming. Concept-oriented is good, and like I said, if you're introducing concepts in a class, in any subject, concepts exist. So it can be very good. Then abstract-oriented is when you're introducing a new tool or even giving a history of a particular application or a particular device that is going to be used. Do we have any question? Do you have any question? No? Okay, I'm going to ask you. Yes, please. No question?
Yes, no.
Okay. Okay, so we are this basically covers ICT teaching methods. I'm going to develop a quiz, which will be your second assignment, and put it up on Moodle. I will let you know via WhatsApp when it's ready. I should put it up by Friday and inform you. So far, we want to see how much we've picked from what we learned up to now. So that's what the quiz will be based on. And then afterwards, there will be an individual assignment. But our next lecture, I think in our next lecture, you're presenting your assignment. And then then I will be giving you the content on the fourth week, which will actually be looking at the curriculum, the curriculum and areas where we can actually apply our teaching methods. Is that okay?
Yes, doctor.
Okay. If then we are okay, we can end the lecture for today, and I allow you to go ahead to other things. And please also don't forget to ask me any question where your assignment is concerned. Okay. Have